So how do we compare nodes after merge? So here in iteration 1, we know we're going to combine the two least frequently used characters first. So that's going to be the C and the D. Well, in iteration 2, so we've now combined C and D into a single node. We'll call it the CD node. We have to have some way to compare that node with the other two. So A still has the same frequency, B still has the same frequency, but what should we put as the frequency of CD? Well, we have a few options. We could add together the frequencies. We could take the minimum of the two. We could take the max, or we could multiply them together. Well, in our new tree, our new node that is C and D, the frequency of the root of this tree needs to represent how frequently we will pass through that node. And the way to represent how frequently we will pass through the node is to add the combined frequencies of those two nodes. Or another way to say that is to add the combined probabilities. All right, so now let's look at the actual algorithm for Huffman. It takes as input a bunch of symbols and the frequencies of those symbols. So you could really pass these together and say that we have like symbol dot frequency, but I've decided to split them out just so it's easier to see what's going on. Well, we're going to create our forest, and essentially we're going to put every single symbol into its own tree to begin with, a single node tree. So each is the root of its own tree. And I'm going to do that by putting all of these into an array. And I'm going to zip together symbols and frequencies. And for those of you who don't know what zip does, it just takes the first one of this and the first one of this and assigns those to F and S that I can use over here. And then in the next iteration, I'll take the second one of these and the second one of these, assign it to these, and then I can use it over there. So what I should end up with is a list where I've got the frequency of the first symbol. So let's say we've got symbol 1 frequency, and then symbol 1, and then symbol 2 frequency, and symbol 2. And then if we have n symbols, the final element here will be symbol n's frequency, a tuple of symbol n's frequency, and symbol n. Well, the easiest way to operate this is to continually grab out the minimum frequency items. And we have a good data structure for that. It's called a heap. So now that I have all my items into an array, I can call heapify on that array, which is a big O of n process for constructing a heap out of the elements in an array. And those elements do not have to be in any sort of sorted order. So instead of entering each element one at a time, which is big O of n log n, we can just do it all at once and end up with a more efficient algorithm. Okay, so now we're going to continue until we have a single tree. So while our forest has more than one tree in it, we extract the two minimum trees. So we're going to extract them based on the frequency. And then we're going to merge them together. So if we have tree A and tree B, we'll merge them together. And now this new node here is going to be the merge node, and it's going to have a frequency of whatever the frequency of A was plus whatever the frequency of B was. So that's what our merge operation is going to do. Next, we take our new tree and we add it to the heap. So this is a big O of log n operation to add something to the heap. And that's pretty much it. So we just continually extract two trees and then replace them with a single tree. So we know that eventually we'll get down to only one tree remaining in the forest, and then we just return that single tree. So now we have our mechanism for encoding and decoding the input. So let's go through one example of doing so. Okay, so we first put all of our nodes into single trees. So we would have 3A. So here's our heap. 2B. 6C. And 6F. Next we would heapify this thing and end up with it's a min heap, and we'd end up with the minimum values at the front or towards the front, I'm not going to worry about redrawing that so that it's in a min heap. Let's just assume that I can, pluck out the 2 minimum values at any given time. So what are the 2 minimums to start with? Well, the 2 least frequent items would be the B and the E. So we'll pluck both of those out, so they're no longer in the tree, and we'll create a brand new node and add it to the tree. To the heap. Let me just erase that there. And so I've extracted those both out, and what we add to it is something that has a frequency or frequency of 4, so those 2 combined, and the symbol we'll just call it BE. So now those are no longer in there. So we've reduced the size of the heap by 1. Okay, so if we want to look at this in terms of a picture also, we could draw this as B and E, and they have a parent node. And we might as well annotate the tree and say, B has 2, 2, and this internal node has a frequency of 4. Next time through, I pop off the 2 smallest, which would be the 3A and the 4BE. And I'm going to combine those into, 7 as the frequency, and we'll call it A. Just trying to find the best way to denote this. Let me fix that for a second. Okay, so let's denote that with A, and just as a reminder that B and E are together, I'll put those 2 in parentheses. So we know our A node will be at the same level as the node right next to it, and we'll give that one a parent. And there's no reason that I couldn't put A on the other side. I'm just going to try to be consistent here, and to do that, I'll put the nodes in alphabetical order for the most part. Okay, so now we can scratch off A and this joined node. And in the interest of having space, I think I will erase all of this and just leave the nodes that we currently have. That way I can keep growing the tree up. Okay, so now we're going to pluck out the next 2, which would be 6C and 6F. We'll create a new node from those. And add it to the heap. And for now, since we don't know how it'll be combined into the rest of the tree, I'll just draw it sort of anywhere there's space. And we cross those off. So now we'll next combine the 7 and the 8. And since the D comes after the A alphabetically, I'll move it to the right of there. So we'll put D here and a parent like that. We should create our new node, which is A, B, E, and D, and then cross both of these off. Okay, so now we just have the final 2 trees to combine. So we'll give them a parent, and I'll just move this tree over there. All right, so there's our final tree. And if you want to know the encoding for any given letter, every time you go left, you'll mark it as a 0. So that would make A 0, 0, 0. B would be, 0, 0, 1, 0. C would be 1, 0. D is 0, 1. 2. E is 0011. And then finally F is 11. And that's our encoding and our process for building the Huffman tree.